Okay, good morning. We are going to talk about NetFlow today. And I apologize in advance. There's only so much I could do to make this interesting. It is, however, valuable. And if you stick with me to the very end, I've got a little surprise for you, made just for you. All right, so we're going to talk about NetFlow and understanding like how to utilize it to detect malicious activities or conduct network analysis. And next. All right, so whether you're monitoring corporate network or investigating an incident or just like trying to hone your skills a little bit, NetFlow is a good opportunity to get that like first line of defense or the first line of analysis, as it is network conversations that we're listening to without having to hear the words. That's my analogy, I guess. So it's all the information about the who's talking to who, when and where and all that stuff, without having to hear the details. So I guess I'm getting ahead of myself a little bit. We're gonna spot some threats and do some practical analysis through demos, and I'll even give you a new tool at the end if you want it. Okay, so NetFlow is the higher level. It is the abstraction and the higher level of packet analysis. So it doesn't have deep. It is not deep packet inspection or full packet analysis. It is above that or below that. I guess it's the lower layers of that. So we get things like IP addresses, source and destination, ports, protocols, bytes, and we can do math with that, and then timestamps. So you know when a device was talking to another device on what port, and that's pretty handy. So like typically, I guess I remember it being like that initial dashboard, no matter what tool, like it could be you know your network monitoring tool itself specifically, or even a SIM has dashboards or cards around these identifiers, so these attributes, so the IP addresses, destination and source, the ports, the protocols, etc. And then you just drill in from there to get the full details, context added from something like a SIM. But again, it's like that first look that you get to recognize anomalies or hopefully not. Okay, it's generated by network devices or software, and it is light. It is technically lighter than full packet captures. So if you were doing full packet captures on everything that you're getting NetFlow on, it is true that it would be more resource intensive. However, I don't want you to think that it's not resource intensive because it's not full packets. Turning on NetFlow on a corporate enterprise network is a major undertaking, and it requires a lot of resources. Like I said, resources enough. Okay, let's get to it. So we're going to use nfdump entirely for this video here. It is not installed by default in Kali, so I've already installed it on mine. But you know how to install a package at this point. And so some basic usage is like just I've got a capture of NetFlow, and I want to just view the whole thing. So that's this first command here. Oh my. That's this first command here. I wish I could highlight here. I'm not going to try to figure it out live. All right, and then we can do some basic. So again, at the basic level, we can filter by attributes. These look familiar. This is your same capture or display filter on any other network analyzer like Wireshark, T-Shark, etc. And then yeah, and then like we can sort. We could do some sorting and aggregation. I'll get into the aggregation a little bit later, but at the very least, we could sort by, biggest biggest number of packets, or like port number, like what the highest port number is or something. Okay. I'm going to give you a couple examples of things we might be looking for, or like given a huge NetFlow data set, what are some things we could probably be looking for? And so this is going to be what I used is I used my Windows box to generate like scripted NetFlow over to my Kali box, so it looks very clean and very regular. The idea is the same, but you have to kind of imagine that the data that you're trying to sort through is more than 2 destination ports, right? Like you can imagine just your home network, if you were running NetFlow capture, would be all over the place. All right, so this is going to be like relatively clean data, but you can imagine like on a big network it would be a little more interesting. Is that too small? Might be too small. All right, so we're going to use nfdump. Wait, let me show you where I'm at here. Okay, so what let's do star.flow. All right, so I've built these files. As you learned if you watched my last video, I can name the extension whatever I want. .flow is obvious to me what it is. It doesn't really actually have to be, the proper capture extension, at least while I'm working with it in the command line. Now, if a particular visualization tool, or I'm trying to upload it to a network monitoring device or something like that, then maybe it's looking for a particular file type, and I have to make my adjustments there. But for our purposes today, I can just name it flow, and it works. Okay, so I'm going to do nfdump on these, and I'm going to read the file. And what I say, strange port. All right, so I've got a flow, and you can see here it's got regular traffic in it and then weird traffic. What I'm trying to identify, obviously, is the weird stuff. And again, like it's a little bit hard to replicate easily, at least for me. So if you know how to do it better than me, let me know, please. But you can see like most of the traffic is just regular web traffic. Somebody's surfing insecure internet, and then just a tad of it is the super elite, whatever that might be, probably legit. So that's it. I'll go into it later, but this is a small data set, and again, like you could point this at a very large data set with many capture files, and effectively get the same thing. And then you sort and slice and dig in based on what you find. Okay, pretty straightforward. Here's another example of knowing I know that I'm looking for something weird. Something weird did happen, or I know about a thing, or there's an IOC out there that's telling me, I don't know, like some particular malware. Well, this one, like this interpreter shell is running on our network. Let me just check for that at a regular interval. Maybe I can script this out and automate it. But let's go ahead and do it. What'd I say? Known bad port. I forget what I called them all. All right, so I'm looking for something specific. In this case, I'm looking for port 4444. And lo and behold, there it is. So that's not super exciting, but that would be really exciting if you had this, if you're looking at your whole network capture for the day or whatever, for work, and you found that port actually is you find traffic on that port. So it's not exciting in a scripted, what do you call it, curated environment, but in real life that would be pretty. You'd get pretty entertained pretty quick. All right. Okay, so we can aggregate stuff, so we could sum up the things that we're looking for, or the things we care about. So like this, an example of this is finding the noisiest host. So I can find the endpoint, source or destination, which is making the most noise. It's or I can sum up like the amount of bytes per. Yeah, I guess that's it. Bytes per host. And then, yeah, let's just do it because we can. nfdump r, this is, next slide, spike. All right, so what I'm doing on this one is I'm aggregating on the destination port. So I want all of the traffic that's going. I don't want just my one IP on that port. I want to see which port is getting the most action. That's kind of what I'm looking at with this one. So in this case, which port is getting the most action is 8080. And so my file name is spike 8080. So I like spiked the traffic way up on 8080 to get that to happen. You can see, there's many more bytes than there are of the others. Now, I don't know if that might be what I'm looking for as a network administrator, and and everybody's complaining about bandwidth or everything's slowing down, and I'm like wondering what the heck is going on. It could be some runaway something, and I can pinpoint it there. And that could be true also for data exfil or other malicious activity or nefarious activity. More likely, however, I would want the inverse of this. So I would want like the sneaky stuff. Like, why is it? It's not regular enough to be in the noise. It's like below the noise floor, so it never kind of raises up into my graphing, or it's a small sliver in my dashboard. I guess if it were presented to me in a dashboard, maybe I would recognize that. But here we are in the command line. That like less, the less traveled path might be more interesting, I guess. Again, like all this is just pointing you to the starting point for your analysis, right? So you're gonna this initial triage, I guess, is kind of the right way of looking at it. Is just going to point you in the direction of what you need to go figure out, really. And and so that's a good one. I think I had, so let me go ahead and show you real quick. So I'm in this folder here, and I've got it. I did it again. So I've got that many flow files. If I back up one, then actually, let me go back in there. I'm going to do what I just did. So I'm going to like aggregate on the destination port and order by bytes. So I want the port with the most bytes to be first. Okay. And this is what we have, right? So 8080 at the top, and there's a handful of things. Okay, if I back up and I switch, instead of pointing to a file, I do recursively on the folder that contains all those packet captures or those NetFlow files. I have a different result. So you can see a couple extra things. 8080 still at the top here, but very closely following is 1, 2, 3, 4, 5. That wasn't on there at all a minute ago. And 5, 4, 3, 2, 1 wasn't on there. I don't even think DNS was on there. Oh yeah, it was on there. Okay. But you can see there's a couple new ones here. And that's because the numbers are different because I'm looking at the full data set, not just the one file. so that's pretty handy. That saves you a little bit of time, right? Uh, let me get back in there before I forget to do that. Okay. All right. So spotting malicious activity, like what are we going to do? We're talking about like the patterns or the anti-patterns that activity manifests. So you got a bunch of port 4444 or 1337 or whatever it is. Um, hopefully it's, I guess hopefully it is that obvious, but rarely is it. And then constant chatter to one IP. I kind of mentioned like that regular communication with a. I guess I'm always assuming external IP. It could be internal, but whatever. It's you're with an IP, no matter time of day, day of the week, whatever, right? So that could be some CD2 traffic. It could be some beacons. It could be any number of things. And then for bandwidth problems or DDoS or anything that's causing a lot of chaos, this would be a good way to narrow that down real quick. So these are kind of the early warning signs. Again, like your first line of defense or your first peek at the problem, I guess, as you're trying to solve it, and then you just drill down and get into the details from there. So you're looking at again, unusual ports, persistent connections to IP, to a single IP, and then weird, not that they're unusual ports, like they shouldn't be used. Like if your corporate network doesn't have FTP running anywhere, and you're seeing that, then that's weird. Or if there's DNS going somewhere that doesn't make sense, like you have your internal DNS servers so you can control that, but it's sending out, or it's hopefully you've got that blocked, but it's sending to another one internally. Maybe it's some sort of data exfil technique. Just again, you're looking for that nuance and the anomaly in the call records. We can look for, so we kind of went over these in demo and example here, but the loudest hosts, like who's causing the most traffic, unusual ports, high flow sources, short duration flows, like short bursty stuff. Maybe it's normal, maybe it's not, up to you to figure that out. And then, yeah, okay, you get it. One final thing is, well, I guess it's not final because it's not the last slide, but the last command here that I'll give you is, similar to what we did before, but in a way that changes the fields that you get presented. So earlier when we did, you could see still up here, like we did an aggregation of the destination port. But if we instead search for and filter on the destination port, then we get an entirely different output. So this is one of those things where like the command line is, it's a blessing and a curse. The barrier is just you reading the manual and figuring out the switches and the syntax to get what you're looking for. Like odds are it's capable, right? And you just need to figure out exactly how to get the information that you want. Okay, so your analyst workflow is get the data, filter it, carve it up, drill down, and investigate. And then that is the infinite loop, right? So that goes back to going and getting more data, or filtering further, or and then back to investigating more. I did want to call out that you can merge files. So that's what I did here. So some of these, actually all of these, produced initially more than one capture file, and I'll just do it for you. So let's call it whatever, demo, nfdump. So I just have to keep reading files and then finally write out what I want. So it can It's like catting everything and echoing it into a new file. So I can do, let's see, sure, spike and strange port. And then I'm going to write it out to demo.flow. And so if I see that, so demo flow, there we go. And that doesn't look like it worked at all, size-wise. It did work. All right, I'm going to play with it. It did work because that's how I built, or it does work because that's how I built all of these. Okay, and then again, like the command line it'll do the work, but it's not very fun. And it could be quick, it could be scripted, which is nice, and there's a lot of benefit to it. But man, I like looking at a dashboard. So you could export this to a CSV, and then use your Excel or Sheets or whatever you're using to then build a pivot table or insert a chart, like do a time series chart or something like that. And now I spent 20 minutes here talking about NetFlow, and if you're still awake, I appreciate it. And I promised you a gift at the end, or something that may be a value to you if you stayed this long, and get us away from the command line. Maybe there's a better way. I was really struggling to find like an easy, ubiquitous way to do NetFlow analysis without paying for it, I guess. So I ended up just building something. So we've got a repo out now public. So it's called NetFlow Visualization. OTA LLC is our account, and so you can go there and get this if you're so inclined. I think it's pretty slick because you could just forget about all this stuff I just did, all this stuff I just showed you on the command line, and just run this command. So first of all, I'm going to get a virtual environment. I'm going to source my activate for that, install my pip packages, my dependencies, and then I'm going to run my script against a file. And now that I'm saying it, I should have made it so that I can also run it against the directory, like I can with dump. But but it's 2:15 in the morning, so I'm just not going to do it today. So I could point it at a file. One of you, please, like make a pull request for it. So I'll point it at one file, and what's going to happen? Like, okay, already done. So this image that just popped up is underwhelming. It's not going to be good because it was a very clean data set. If it was not a clean data set, this would be way more interesting. Which, again, if it wasn't 2:15, I'd probably make a dirty data set. All right, but I can get enough variation here, even with just the clean stuff that I have here, the little bit that I did, and show like, here's my distribution by destination port. Good to know. Like that is way easier for me to visualize and immediately spot what I'm looking for than digging through all the packets. Now, that might get really crowded if you got a whole bunch, like a whole range of destination ports. This again would be way more entertaining if you had all of the protocols flying across your network. I was able to replicate these. And then noisiest host. Again, you might be looking for the noisiest host. You might be looking for the quietest host. Maybe it's none of the above, but there's your distribution. So that's top 10, and that's what you get. So it pops up all those images, which is neat. And it also, I guess it's obvious that it saves those. So in that same folder, so that's where we're at, right? So NetFlow data. Yep. So here's all those images, and then in hindsight, I'd probably what I was trying to demonstrate was a time series analysis of the bytes, like how much traffic over time. But it turns out my traffic was perfectly consistent because that's how the tool works. Um, so in hindsight, I probably would have done a different graph, but we have a little bit more of an interactive chart in HTML here. So again, given real data and dirty data and a lot of it, like this would be more entertaining, and it would be more akin to what you would see as a dashboard card on a real network tool or SIM or something. But anyway, it's something. It's a start, and by all means, contribute or just use it and give me feedback. Okay, at the very least, I snuck a couple pictures in there, so it spiced it up a little. That's all I got. That's NetFlow. Thanks for watching.